Decide whether the relation defined by the graph to the right defines a function, and then give the domain and the range. So we want to first determine, is the graph a relation defined as a function? So let's take a look at this graph. Okay, now we have what we call is the vertical line test. Okay, so if it passes the vertical line test, then that means that it is a function. So what does it mean by a vertical line test? If I draw a vertical line through this graph, okay, you can see that there's one output, okay, up here, which is a y value that corresponds to one x value. Okay, same thing, no matter where I put the vertical line, it's only going to pass through one point. So again, here is a point on the line. It has one y value and then one x value. So therefore, the vertical line test is telling us that this is a function. But let's go ahead and check this out in words. So to determine whether the relation represented by the given graph is a function, we're using the vertical line test. So if each vertical line intersects a graph no more than once, which it does here, the relation is a function. This graph satisfies the vertical line test because every vertical line intersects the graph of the relation no more than once. Now this graph is the graph of a function because the graph then passes the vertical line test. Therefore, the relation represented by the given graph is a function. So we're going to go ahead and say yes, and there is our result. Now we got to determine what is the domain of the graph relation. Okay, so now in order to find the domain of this function, okay, we need to take a look at all the x values that correspond to this function that's graphed. Okay, so if you notice here, along the x-axis, okay, it's going from negative infinity to positive infinity. And the way we know that is by the arrows at the end of the graph. That means it continues. So that means it's continuing from negative infinity to positive infinity. So therefore, this represents the domain. It's going from negative infinity to positive infinity. So let's go ahead and write this here. So the domain is the set of all the x values of the points on the graph. Note that the arrowheads indicate that the graph extends indefinitely to the left and then to the right. So let's go ahead and put our answer in here. So the domain in interval notation is parentheses negative infinity, comma, positive infinity with a parenthesis, and check our answer, and there is our result. Now the next question says, what is the range of the graph relation? So again, let's take a look at the graph. Okay, now when we look at the range of this function, it's going to be all the y values. Now if you notice here, here is the y-axis that represents all the y values. And so down here, it's going towards negative infinity for y. And then up here is positive infinity. Now again, if we look at these arrows on the graph, it means it's continuing. So to find the range of this function, it's going to be the same as the domain. And we're going from negative infinity to positive infinity. Now again, if we use this in words here, again, the range is the set of all the y values of the points on this graph, and the arrowheads indicate that the graph also extends indefinitely up and down. So therefore, let's put our answer in here. We have parentheses negative infinity, comma, positive infinity. Check our answer, and then there is our result.